Alright, in this video I'll be focusing on the unit circle, especially when you get to chapter 6 and you're solving trigonometric equations. The unit circle is very valuable when you're trying to find solutions. And so let's go ahead and talk about that. And so first of all, we talk about this in terms of circular functions, which really are trigonometric functions, and that's the 6 functions we've been working with. The thing that's changed here is now our radius is 1. We don't call it r. And when you do that, the nice thing that happens is it turns out that in your points along the circle, the x value is equal to the cosine of your angle theta, and the y value is equal to your sine of theta. And so, for example, if I want to find the sine of pi over 6, that's just the y value of this point, which is 1/2. Sine of pi over 6 is 1/2. And so if you know this unit circle well, and by the way, you ought to be able to generate it. You could basically start by doing this quadrant here, and then you could figure out the others because the only thing that change are the signs. So you should be able to draw this unit circle. I don't normally draw the whole thing. I just draw the pieces that I need. And so, and I'll show you that in just a couple minutes here, or just a minute or so. Actually, I think we will go ahead and get started. So let's find some values. What if we want to find the sine, or if we know the sine of theta equals 0, I want to find out where that happens. Well, remember, sine is the y value of our points. So we want to know where are the y values 0. Where that's going to happen here and here. So that happens at 0 and pi, or 0 degrees and 180 degrees. What if I said cosine of theta is equal to -1? Well, again, cosine is the x value of our points, and there's only one point that has an x value of -1. So basically, you're going along the x-axis, and you know that the farthest you can go is -1 because that's our radius. So you're never going to get bigger than 1 or -1, or I should say bigger negative than -1. All right, so that happens here at pi, where theta equals pi. What if we had sine of theta is equal to 1/2? Well, let's see. We know, again, sine of theta, that's the y values. Notice that happens at this point here and this point here. That's where our y value is 1/2. That's at pi over 6 and 5 pi over 6. What if we had cosine of theta equals -√2 over 2? Well, hopefully you recognize that's going to happen at one of your multiples of pi over 4 or 45 degrees. Well, notice here our x value is positive and the y value. Cosine is going to be negative, or we should say x is negative, basically on this side of the graph. When we go over here, x is negative. And so we're looking for the x value to be -√2 over 2. That happens here, and it happens here. So that's at 3 pi over 4 and 5 pi over 4. All right, tangent of theta equals -√3. Now we know tangent is sine over cosine, and so in the first quadrant, tangent's positive, and the same thing is true in the third quadrant because you have a negative over a negative. And so we know that tangent is either going to be over here or over here. It's going to be both. So, and then the other thing I know is the square root of 3, that's going to happen at either my multiple of pi over 3 or my multiple of pi over 6. It's going to be one of these 2 points. All right, so we want tangent, which we know is y over x, to equal -√3. Well, in this case here, our y value would be the square root of 3 over 2, and our x value would be negative 1/2. And so I got lucky here. It's this point because I have square root of 3 over negative 1 or negative square root of 3. If that had not been the right point, I would have used this one, and we would have got it here. But we're good here. So this occurs here, and it's going to occur on the opposite side at 7 pi over 4. So 3 pi over 4 and 7 pi over 4. All right. What if we had secant of theta equals negative 1 over the square root of 2? Let's see. Yeah, negative 1 over the square root of 2, which we know is also equal to negative square root of 2. Actually, I'm messing that up there. That should just be negative square root of 2. Well, we know that secant is equal to 1 over cosine. And so this could be, we could actually just look at the reciprocal here, negative 1 over the square root of 2, or negative square root of 2 over 2. Now, cosine, remember that's our x value, is negative square root of 2 over 2. Well, the x value is going to be negative square root of 2 over 2 here, and also here. And so that happens at 3 pi over 4 and 5 pi over 4. All right. And I think that is all I want to do here. So anyway, we've seen, we've done a review of all the different ways that, or I should say the majority of the ways that we've found our trig ratios. And especially in chapter 6, I would encourage you to use the unit circle to help you when you're, because a lot of times you're going to have multiple answers. And so you'll be able to see those quite easily on the unit circle. If you're using one of the other methods, that's fine. All right, that's it for this video.